Now this question says, given that fx is equals to 1 over x, the tangent of AB is drawn and the point of tangency is at D, which is A and the function of A. Now they say show that the equation of the tangent is equals to this here. Now one thing you need to understand about the equation of the tangent, now a tangent is a straight line, and a straight line would always look like this. Okay, so now for me to find my tangent, I would need to figure out what the gradient is. And not only do I figure out the gradient, I need to at least figure out a point. And that point is very important, okay? So if we have the x, because in this question here, we can see that the x is a, right? The x coordinate of D is a. So I could say here, if x is equals to a, y will be equals to, now I need to just substitute the equation of fx, right, which is 1 over x. So this here is 1 over x, so we can say y is equals to 1 over a. Okay, so we have our coordinate here, right? Our coordinate for this is going to be a and 1 over a. Okay, now we have that. Now the next part we also need to figure out is our gradient. To figure out our gradient, we understand that a derivative is equals to our gradient. So if the original fx is 1 over x, we know that if we can try to derive it, I'm going to just rewrite it first of all, then differentiate. This here will give me negative x, negative 2. So I could just write it as negative 1 over x squared, okay? So my derivative is negative 1 over x squared. To get the gradient, we need to substitute the corresponding x value into our derivative, and that gives you your gradient. And since our x value is a, we are literally substituting a into this equation, right? So I'm saying that it is f a, and that will just give me negative 1 over a squared. Okay, so now that's my gradient. I have the gradient, check, and I also have a point, check. So now I can substitute it into any formula that I want to use, but I prefer to use this. Y minus y1 is equals to m x minus x1, right? So substituting each of our values for y1, x1, and m, this is what we're going to get. Okay, now we also notice here that since we're working with fraction, we have an LCD. The LCD here will be a squared, right? So multiply everything by a squared. This here will give you. Then now we can open out the bracket and simplify as best as we could. And the question wanted x plus a squared y is equals to 2a. That's it. A squared y plus x is equals to 2a. And we just proved that our tangent would be equals to this equation we see down here. And that's it.